I was just trying this problem yesterday. Even checked for the textbook. Even the textbook has the same the question framing. There is no data missing in this particular problem. Okay, so I just came up with this particular solution after referring all the textbooks. What best we can do is that we can treat this as a single whole process from 3 to 6, a single expansion process from 3 to 6, and then applying the PVT conversion equation for the process 3 to 6, which is adiabatic expansion, and then getting the value of 6 dash. From 6 dash, you can arrive at the value of 5, that is T5. So this is the best method I can figure out. Okay. So apart from that, if you find any other good option, you can just share me. Okay. Is that fine? Shall we go with this? Treating as 3 and 6 as a whole process, 3 to 6, and calculating the value of 6, because both are of the same pressure lines, no? Shall we try that?
Yes, sir.
Yes, sir.
Okay. Now, all of you just write. Considering the full expansion, that is from 3 to 6, which is adiabatic, now applying PVT conversion equation, we get, yes, what we get from process 3 to 6, it is P3 divided by P6, that is equal to V6 divided by V3 whole to the power of gamma, that is equals to T6 divided by, T3 divided by T6, T3 divided by T6 whole to the power of gamma divided by gamma minus 1. And what is gamma value for expansion process?
$1.333.
1.33, and the P3 value is 7.07 bar, and P6 value is 1.01 bar. So when I'm picking those two values for my calculation, so P3 value was how much? 7.07 bar divided by 1.07. Alado P6 ಎಷ್ಟಿದೆ? 1.01.
1.0.
So 1.01, that is equal to, what is the value of T3, guys? What is the value of T3? 883, na? So 883 divided by T6 whole to the power of gamma is how much? It is 1.333 divided by 1.333 minus 1. So from this, what is the value of T6? Okay, so 543.056. So T6 is equals to 543.05. I would take that value, 0.05 Kelvin. So this is the value of T6. So once I have got the value of T6, I think there would be no difficulty in calculating T5 now. So applying PVT conversion equation for what? For the process 5 to 6, which is adiabatic expansion. Okay, when you apply this, what happens? It is P5 divided by P6, that is equals to V6 divided by V5 whole to the power of gamma, that is equals to T5 divided by T6 whole to the power of gamma divided by gamma minus 1. Okay. Now, what is the value of P5? P6, I know it is 1.01 bar, 1.01. But what is the value of P5? T5 I need to calculate. T6 I have obtained as 543.05 whole to the power of 1.333 divided by 1.333 minus 1. Now, what is the value of P5?
1.656.
1.656 is the value of P5. So it is 1.656. So from this, can I get the value of T5 in Kelvin? Okay, so it is 614.44. Is the value correct?
Yes, sir. Correct.
Good. Now, T5 we have obtained, T6 we have obtained. Should I convert this to T6 dash and T5 dash? Is it necessary?
T6 dash we need.
Yes.
So efficiency is given, then we have to know.
I think there is no requirement of calculation of T5 dash, isn't it? Only there is a requirement of calculation of T6 dash, right? Am I right?
T6
Yes.
Okay, very good. So now calculating T6 dash. How do you calculate T6 dash, guys? Any idea? Now I want to calculate T6 dash. I have the value of T6. I want T6 dash. What should I do?
actual efficiency of turbine is equal to actual work divided by isentropic work.
Actual work divided by isentropic work. Okay. So this particular turbine is which turbine? Whether it is high pressure turbine or whether it is low pressure turbine.
Low pressure.
It is a low pressure turbine. So what I do is I just write efficiency of low pressure turbine. So the process takes place from low pressure turbine process takes place from 5 to 6, I guess. So how will you write the actual work? It is mCp into T5 minus T6. But since there is a actual work, so you need to have a dash there. Isentropic is same thing, but without the dash. Now these two will get cancelled. Whatever is remaining is T5 minus T6 dash divided by T5 minus T6. And can I know what is the efficiency of LP turbine given in the problem?
0.85.
0.85 is equal to 614.44 minus T6 dash divided by 614.44 minus T6 value is how much? 543.05. 543.05. So from this, can I have the value of T6 dash?
Five 553.75
How much?
553.75 Kelvin.
553.75 Kelvin. And I don't have the entire solution of this, but I have the final answer of it. If the final answer matches, the whatever procedure we have followed is correct. So that is what I'm trying to do. T6 dash we have got. And next, we will be in a position to calculate this one. The work done by a low pressure turbine. So I'll just copy that, paste it here. Now, from this, what is the value of Cp for an expansion process?
One point 1.15.
1.15. So it is 1.15 into this, and whatever the value I get, that would be in kilojoules per kg. So the work done by low pressure turbine is equal to so much.
$69.79.
How much?
69.79.
69.79. Can I approximately take it as 70 kilojoules per kg? Now, the second thing what we were calculating is W net. Is the W net. So W net is 3 works are there. One is compressor, one is high pressure turbine, and one more is low pressure turbine. So the compressor work was minus something 262 in it. How much it was that, Sujan?
minus 262.47.
Minus 262.47 plus 262.47 and plus 69. I will take it as 70 there, plus 70. So whatever the value of W net I get, which was the second subbit which was asked, I would take it as 70 kilojoules per kg, and this is the output what I get from this turbine. Okay. Is that clear? Everyone is getting the same value. If you get the same value, just raise your hand. 70 kilojoules per kg. Good. Good. Okay. So the third subbit, what is the third one asked?
Work
What is
ratio.
the third one asked? Work ratio. So work ratio. So how will you calculate the work ratio? Yes. How will you calculate the work ratio? Yes.
W net divided by
So it is W net divided by
high pressure work plus low pressure work.
ಅದೇನದು ಯಾಕೆ ಹೈ ಪ್ರೆಷರ್ ವರ್ಕ್ ಲೋ ಪ್ರೆಷರ್ ವರ್ಕ್ ತಗೋಬೇಕು ನಾವು
Positive work.
Very good. That is what the answer I have needed. So positive work. So W net in the sense it is the value which is 70 kilojoules per kg. Positive work which is generating positive output. So positive output. So what else is generating positive output? It is HP turbine which is generating positive output, and it is low pressure turbine which is generating positive output. Now from this 70 divided by HP turbine is 262.47 plus 70. So what is the work ratio?
Zero 0.21.
So this is the work ratio. Next, what else you have to find? Fourth one.
Efficiency of Brayton cycle.
Efficiency of Brayton cycle. So for that, what is the, how will you calculate? It is output by input. Okay. What is the output? Output is the value of W net. What is the input? So heat input you have to take. So heat input you are given in how many stages? First you are giving in a combustion chamber. Next you are giving in a reheater. Isn't it? Two heat inputs you are giving. So it is W net. divided by combustion chamber. What is the equation? 2 to 3, na?
Yes, sir.
Reheater ಗೆ
4 to 5. 4 dash to 5.
4 dash to 5. Very good. And this is also 2 dash to 3, I guess, right?
Yes, sir. Yes.
Okay. Now, you must calculate what? I'll just write it here itself. No issue. Here, here, 2 dash to 3, you have to calculate. Again, it is MCP delta T, but for heat, it is final minus initial. So it is T3 minus T2 dash. Considering it for the unit mass basis, it is Cp into T3 minus T2 dash. What is the value of Cp? What is the value of Cp? You can take before for the combustion process, what is the value of Cp? He has clearly mentioned here. It is 1.15 for the combustion and expansion. Okay, 1.15. Take that value, it is 1.15 into 883 minus what is the value of T2 dash? Please help me out, guys, otherwise I have to keep on scrolling the things. What is the value of T2 dash?
549.17.
549.17. Okay, thank you. Now, what is the value of Q2 dash to 3? In kilojoules per kg. Similarly, you can calculate the value of K4 dash to 5, which is Cp into final minus initial. So T5 minus T4 dash. Cp is 1.15 for the combustion. T5 value was to Madipula. It is 614.44. 614.44 minus what is the value of T4 dash? T4 dash, have you calculated?
$654.76.
What is this 54?
T4 dash.
554.76. Correct?
No,
Now
sir.
give me
654.
654. 654.76. Eager, give me the value of this Q2 dash to 3 and Q4 dash to 5. Okay, I think there was some problem with my connection. Can you give me the value? Okay, minus 46.
Yes, sir.
Okay. This value is wrong, guys. It shouldn't be minus because reheater you are adding the heat. How can it be minus? It's wrong. Just check with the efficiency of the breakdown cycle how much you'll get. Just to check the value of what I have got. So W net is 70 divided by 383. 383.90 minus 46.36. How much is this value?
70%.
How much?
20.73.
20.7, and the value is 100% correct. Okay, typical problem. The textbook value was 19.9. That means approximately 20%. We have just got above it. And the work ratio textbook answer is 0.215 and we have got 0.21. That's correct. So whatever procedure we have followed is correct. I don't know. I'm really shocked to see a minus sign here. Okay. We don't have a solution, but yet the answers are correct. Okay. 0. And the net, this one, the work net, W net value was 72.51. Textbook answer 72.1 kilowatt. So we have got 70 kilowatts. That's fine. Okay. Well done. Good man. So this is how we will solve the problems. This kind of problems are very rare in our examination. Don't worry about it too much. But rather, sorry, if you solve these kind of problems, you'll get good grip upon your subject. Okay, so that was the intention. So I have just picked up this particular problem with unknown solution, but the solution was not given. I picked up and I was just solving it. Okay. And any doubts in this problem? Anything to be discussed? And your internal papers is being evaluated. And I am shocked that everyone have chosen the same question, that is 1, 3, and 5. How come it is possible, man? I'll just stop the recording.